Welcome to C and C++ programming under APG Pathshala. Today we will start with module 40 templates. As we have seen in earlier modules the concept of user defined function. Suppose we need to write a swap function to swap the two integer values, then we write the user defined function where two parameters will be passed will be of type integer. Now if I want to write the swap function of characters, then the second function will be written where two parameters will be passed of type character. If next we want to swap the two double values, then the third user defined function swap has to be written where two parameter values will be passed of type double. So as you can see, depending on which data type the swap function will swap the values, you have to write those many swap functions. Now this particular problem will be solved using the concept of templates. Now instead of writing 3-4 different templates for different functions, what we can do is we can make use of the template function where it will be written only once. So template function will be written as a swap template where a data type and the parameters will be taken as the argument. So to swap two integer values or character values or double values, we have to write only one swap template where the data type, whether it is integer, character or double, will be accepted from the user at runtime. This is the biggest advantage that template is going to give us. To write the functions of different data types, we can use the concept of templates. Templates will give rise to something called as generic programming or generic code. So here the data type will be accepted at runtime. Template is nothing but the blueprint for the function which we are going to use in our program, and in this function the data types will be accepted at runtime. So let's start with the concept of templates and see some more details of this particular concept. The templates offer generic programming by defining general classes. In templates, the generic data types are used as parameters so that they can handle a mixture of data types. The templates assist the programmer to declare a collection of functions or classes. When the templates are used with functions, they are called as function templates. When the templates are used with classes, they are called as class templates. Now let's see the learning objectives of this module. We will study about the need of template, we will learn about the function templates, we will learn about the class templates, we will know about templates with multiple parameters, and we will study about standard template library, that is STL. A template is a method that permits to use a single function or a class to work with dissimilar data types. Using templates, it is possible to create a single function that can process any type of data, that is the formal arguments of template functions are of template type. So they can accept data of any type such as integer, long, float, etc. Thus a single function can be used to accept values of different data type. In general, overload functions are used when there is a need to handle different data type. But this approach increases the program size and also more local variables are created in memory. But these problems can be solved by using a template because it safely overcomes all its limitations and allows better flexibility to the program. Now we will see first the function templates. The function template and function works in the same manner, but there is one difference. It is possible that a single function template is able to work on dissimilar types at one time, but it is must that different functions are required to execute the same task on dissimilar data types. If identical operations are to be performed on two or more types of data, then it is must to use the concept of function overloading. But the better approach is to use the concept of function templates because it is possible to perform the task by writing the smaller amount of code which is easier for reuse. The function template describes the family of functions. Now let us see the syntax to declare the function template. the syntax will be template in angular bracket class type, return type function name in bracket the parameter list and the body of the function in curly braces. Example, template class T1 void swapping T1 ampersand x1 T1 ampersand y1 in curly braces T1 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 is equal to x1, x1 equal to y1, y1 is equal to T1 and end of the function. Now, as you can see here, this is a swap function which can swap the values of any data type. Let us see a program to see the usage of function template. We will start with our program hash include iostream, hash include string using namespace std, template class T1 void display T1 T1. We will start with our function code. See out the value is T1 end L and the function will end. Integer main, integer I1 is equal to 15, double D1 is equal to 15.5, string S1 is welcome to templates, boolean B1 is equal to true. Now, we are going to call a display function with all these data types integer, double, string and boolean. We are going to call a display as display I1, display D1, display S1, display B1 and return 0 and our main program will end. Now, when the above code is compiled and executed, it will produce the result as value is 15, value is 15.5, value is welcome to templates, value is 1, that is true. Now, as you can see, a same function is used for the data type integer, double, string and boolean. Now, here the T1 is a variable which will be declared as integer or double or string or boolean depending on the type of data that is passed to a function. That is basically the advantage of function template. Let us see a program to display a small number among two numbers using the function template. We will start with the program hash include iostream using namespace std, template class T1, T1 small, T1 n1, comma T1 n2. We will start with the function code return n1 less than n2 question mark n1 colon n2 semicolon end of the function. Now, this is a function template small which will find out the small between two numbers of integers or floats or characters and so on. Now, depending on the data type that is passed, if the data type is passed as integer, then the return type of this particular function will be integer. The first parameter n1 will be of integer, the second parameter n2 will be of type integer. If the parameter that is passed is of type float, then the return type of the small function will be float. The first parameter n1 will be of float and the second parameter n2 will be of float. Now, let us start with our main program integer main, integer 1 comma integer 2, float 1 comma float 2, character char 1 comma char 2. So, three variables has been declared of type integer, float and character. See out enter two integers, C in integer 1, integer 2, see out small integer 1 comma integer 2 is smaller. Now, here the integer data type is passed to the small function template. See out enter two floating point numbers end L, C in float 1 float 2, see out small float 1 comma float 2 is smaller. Here two float values has been passed to the function template. See out enter two characters, C in char 1 char 2, see out small char 1 comma char 2 has smaller ASCII value, return 0 and the program will end. When the above code is compiled and executed, it will produce the result as enter two integers. Suppose the two integers are entered are 23 and 45, then it will display the message 23 is smaller. Enter two floating point numbers. Suppose the enter values are 12.56 and minus 7.89, then it will display the message minus 7.89 is smaller. Next, it will display the message enter two characters. Suppose the two characters entered are C and A, small a, then it will display the message as A has smaller ASCII value. Now, let us see one more program to find the square of a number using the function template. We will start with the program hash include iostream using namespace std, template class T, inline t square tx. Now as you can see, this particular function is declared as inline. We will start with the function body t result. Result is equal to x into x, return result end of the function template. Now as you can see here, this particular function is an inline function. The return type is t and it is going to accept the parameter x of type t. So here if the integer value is passed to this particular function, then it will be inline, the return type is integer, name of the function is square, and in bracket it will be integer x, and the result will again be of type integer. Now let us start with our main program, integer main. Start with the declaration part, integer I1 integer result, float F1 float result, double D1 double result. Now we will give the values to I1, F1 and D1 as I1 is equal to 2, F1 is equal to 2.2, D1 is equal to 2.2. Now we will call the function as integer result is equal to square in angular bracket int and in round bracket I1, cout I1 colon integer result end L. Now second will be float result is equal to square is the name of the function template. The data type that we are going to pass is in angular brackets float, and in bracket F1 will be the value that will be passed. Cout F1 colon float result end L. Double result is equal to square double D1 cout D1 colon double result end L. Integer result is equal to square of I1. Cout I1 colon integer result end L. Now the program will end. When the above code is compiled and executed, it will produce the result as 2 colon 4, 2.2 colon 4.84, 2.2 colon 4.84 and last one is 2 colon 4. Overloading function templates. It is possible to overload a function template either by using a non-template function or by using the function template. If the name of an overloaded function template is called, then the compiler will try to infer its template arguments and verify its explicitly declared template arguments. If it is successful, then it will instantiate a function template specialization and then adds this specialization to the set of applicant functions. The compiler continues with the process of overloading by selecting most suitable function from the set of applicant functions. The non-template function have higher priority than the template function. Now let us see a program to implement the usage of overloading function template. We will start with our program, hash include iostream using namespace std, template class t1, void function t1x1, t1y1, cout template end L. This is our first function template that we have defined. Now we will define the second function as void function integer w1 comma integer z1, cout non-template and end of the function. So we have defined one func function as a template function and second func function as a non-template function. Now we will start with our main code, integer main. Now we are going to call a function with func 2 values 11, 12. Next func with 2 values a, b. Now we are going to call a func function with 2 values 11, b. Return 0. Now when the above code is compiled and executed, it will produce the result as for the first call func 11, 12, it is going to match with the template function integer integer. So the message that will be printed on the screen will be non-template. Now for the second, it will be func ab, where a and b are basically of type character. So a template function will be called and the message that will be displayed is template. Now the third is basically the one value is integer, second value is character. So now the non-template function will be called and it will display the value as non-template. Now we will see the program to see the concept of overloading of function template. In this particular program, we are going to define two function templates. The first function template will accept one parameter and the second function template will accept two parameters. Here one thing we have to notice is that in both the function template, the return type and the name of the function is the same. So let us start with our program. First we will start with hash include iostream using namespace std. Now we will declare first two function templates. Our first template will be template class x1 void f x1 a1. Inside this particular function template, we are just going to display the message as cout inside f x1 and our function template will end. Now we will write our second function template as template class x1 class y1 void f x1 a1 y1 b1. Now inside this function template, we are going to display the message as inside f x1 y1. Our function template will end. So here two function templates has been defined. Now let's start with our program. We'll start with integer main. Now we will first give the call to the function template with one argument as f10. Next we'll give the call to a function template with two argument as f10, 20 and our main program will end. Now when the one parameter is passed, the first function template will be called. Where two parameters are passed, second function template will be called. So when the above code is compiled and executed, it will produce the output as inside f1 x1 second inside f x1 y1. Now we will see the concept of a class templates. The class templates are related with the generic types and they can use some particular types also. The only restriction before creating an object of the template class is it is must that the data type must be specified, because all the objects have to be of some definite size. It is possible by indicating the data type as parameter when the object is created for the template class. A class template describes a family of classes. Now let us see the syntax of the class template. It will be template in bracket the class type, class, class name, opening braces, the member function and data members of the class and closing of the class function. Now let us see a program to implement the push and pop operation of the stack using the class template. Now this particular stack can be used for stack of integers or characters or any data type. So this is a complete class of a stack template that we are going to create. Hash include iostream, hash include string using namespace std. Now we will declare the class of a stack as a class template, template class t1 class stack opening braces public colon stack opening and closing bracket, which will be a constructor, void push t1 I semicolon t1 pop opening closing round bracket semicolon, private column integer top t1 st1 100 semicolon and end of the class. So this is a template of a class that we have created, which is of class stack. Now we are going to declare the member functions as template class t1 stack t1 colon colon stack, which is a constructor, top is equal to -1 and end of the constructor. Next will be template class t1 void stack t1 in angular bracket colon colon push t1 I1. This will be a push member function of the class. So it will be st1 in bracket plus plus top is equal to I1 and push function will end. Next is a pop function template class t1 t1 stack in angular bracket t1 pop opening closing bracket return s1 top minus minus end of the pop function. As you can see here, for the push function the return type is void and for pop function the return type is t1. Now we will start with the main program. Integer main stack in angular bracket integer integer stack stack in angular bracket string str stack. Now we have declared here two stacks, one will be of type integer and second will be of type string. Integer stack dot push 100 str underscore stack dot push welcome str underscore stack push class template. Now cout element that is popped is integer stack pop. So it is going to pop out the element 100. Element that is popped is str stack pop. So it is going to pop out the element class template. Element that is popped is str stack pop Now it is going to take out the string as welcome and return 0 and the program will end. Now when the above code is compiled and executed, it will produce a result as element that is popped is 100, element that is popped is class template, the element that is popped is welcome. Now by seeing this particular example, you can see the advantage of the class template. This particular class of a stack can be used for stack of character, string, double, for any data type. Templates with multiple parameters. Now it is possible to specify more than one generic type in the template statement using a comma separated list. This can be appropriate to both the function templates and to class templates. The syntax for function template with multiple parameters is template class T1 comma class T2, return type, function name, arguments of type T1 and T2, and the body of the function, and the function will end. Example, template class T1 comma class T2, void show details x T1 comma y T2, cout T1 T2, and end of the show details function. Syntax for class template with multiple parameters. It will be written as template class T1 class T2, class name, data elements of type T1 and T2, the functions with argument of type T1 and T2, and the class will end. Example, template class T1 comma class T2, class pairs, opening of the class bracket T1x T2y, public pairs T1a comma T2b, void show details, opening and closing bracket, end of the class. Now let us see a program to implement the usage of class template with multiple parameters. We will start with a program hash include IOStrip using namespace std, template class T1 comma class T2, class pairs. We will start with the class code T1x T2y, public pairs T1a comma T2b. Start with the pairs function x equal to a, y equal to b. End of the pairs function, which is basically the constructor, parameterized constructor, void show details. We will start with the member function show details, cout the pair is x comma y in bracket and L, and our class will end. Now we will start with the main program. We are going to call a pairs function with two data types, float comma integer. So the first T1 will be of type float and T2 will be of type integer. Now we are going to call a function pairs with 100, 0.25 and 24. Now we are going to call a member function pairs dot show details. So it will display the values on the screen. Then we will call the pairs char comma integer. So T1 here will be character and T2 here will be integer. Now we are going to call a function pairs in bracket character x, capital X comma minus 25. So we are calling the constructor here. Now we are going to call a pairs dot show details, return 0 and end of the main program. When the above code is compiled and executed, it will produce the result as pair is 100.25 comma 24, and next one is pair is x comma minus 25. So we can have a template or the class template with a mixed data type. Here the first data type was float and second was integer. So multiple parameters with different data types can also be useful. Standard template library. In C++, STL, which stands for Standard Template Library, is a dominant set of C++ template classes to offer general purpose templatized classes and functions that employ many accepted and frequently used algorithms and data structures like vectors, list, queue and stack. C++ Standard Template Library mainly consists of three components. They are containers, algorithms and iterators. Containers. The containers handle set of elements. To meet different needs, STL present different kinds of containers. The different types of containers are sequential containers. They are pre-arranged collections in which every component has a assured position. The location depends on the time and the place of the insertion, but it is independent of the value of the element. Example, vector dequeue and list. Slide number 28. The second type of container is associate containers. They are sorted collections in which the real position of an element depends on its value due to the sorting principle. Example is set, multiset, map and multimap. Iterators. The iterators are things that can navigate over elements. An iterator corresponds to a definite position in a container. The iterators are divided into 5 groups based on the operations they carry. They are input iterators, output iterators, forward iterators, bidirectional iterators and random access iterators. Input iterators, they are read only iterators where every iterated location may be read only one time. Output iterators, these are write only iterators where every iterated location may be read only one time. Forward iterators, they have the ability of both input and output iterators, but they can be read or write a single location over and over again. They can move only in forward direction. Next one is bidirectional iterators. They are similar to forward iterators except they can go in forward and back as well as. Next is random access iterators. They perform like they are bidirectional iterators, but they also represent iterators arithmetic, that is the capability to jump forward or backward in a single step. The vector, string and dequeue are random access iterators. Next is algorithms for STL. The STL provides many typical algorithms for the processing of elements of collections. They can search, arrange, alter or only use the element for dissimilar purpose. The algorithms tries to use iterators. The algorithm has to be written only one time to work with random containers because the iterators interface for the iterators is frequent for all container types. Now let us see program to implement the usage of vector. We will start with program. Hash include IOStream, hash includes vector using namespace std. We will start with our program integer main, vector in angular bracket integer, vect is a object, integer I1, cout vector size is equal to vec dot size endl. For I1 equal to 0, I1 less than 5, I1 plus plus, vec dot push underscore back I1 end of the for loop, cout extended vector size is equal to vec dot size endl. For I1 equal to 0, I1 less than 5, I1 plus plus, cout value of vect I1 is vect of I1 end of the for loop, vector integer colon colon iterator v1 is equal to vect dot begin, while v1 is not equal to vect dot end, cout value of v is equal to star v1 endl v1 plus plus, end of the while loop, return 0, end of the main program. Now when the above code is compiled and executed, it will produce the result as vector size is 0 which is initial, extended vector size is 5, value of vector 0 is 0, value of vector 1 is 1, value of vector 2 is 2, value of vector 3 is 3, value of vector 4 is 4. Next, value of vector is v is equal to 0, value of vector v is equal to 1, value of v is equal to 2, value of v is equal to 3 and value of v is equal to 4. So now in this particular way we can initialize the vector and use the capability and many functions and utilities which are there in a vector class. Let us see a program to implement the usage of the find operation on vectors. We will start with the program hash include IOStream, hash include vectors using namespace std, template class t1, comma class u1, t1 find, t1 first, comma t1 last, comma constant u1 ampersand value. Now we will start with the find function code. While first is not equal to last and star first is not equal to value, plus plus first, return first, end of the function. We will start with our main program integer main, vector integer v1, for integer I1 equal to 0, I1 less than 10, I1 plus plus, v1 dot push underscore back I1, integer x1 equal to 5, x2 is equal to 120, vector integer colon colon iterator it1, IT1 is equal to find V1 dot begin comma V1 dot end comma x1. So, it is trying to find the value of 5 inside the vector. If IT1 is not equal to V1 dot end, Cout found x1 end L, else Cout could not find x1 end L, end of the if condition. IT1 is equal to find V1 dot begin comma V1 dot end x2. If IT1 is not equal to V1 dot end, Cout found x2, else Cout could not find x2, return 0. And our program will end. When the above code is compiled and executed, it will produce the result as found 5, could not find 120. Now, here our vector has been initialized for the values 0 to 10. So, 5 was present, whereas 120 was not present in our vector list. Now, let us see a program to implement the usage of find operation on list. List is another data type which is there in a template class or in a standard template library. Hash include IOStream, hash include list, hash include string. Using namespace std, template class T1, class U1, T1 find, T1 first, comma, T1 last, comma, constant U1 ampersand value. Now, we will start with the function code. While first is not equal to last and star first is not equal to value, plus first, return first, end of the find function. Now, we will start with our main program, integer main, list string str3, str dot push back A, str dot push front B, str dot push back C. String str1 is equal to B, str2 is equal to F. List string colon iterator IT1, IT1 is equal to find str dot begin comma str dot end str1. So, it is going to find the character B inside the list. If IT1 is not equal to str end, then Cout find str1, else Cout could not find str1 end. IT1 is equal to find str begin comma str end str2. Now, it is going to find the character F into the list. If IT1 not equal to str end, Cout found str2, else Cout found could not find str2, return 0 and main program will end. Now, when the above code is compiled and executed, we will get the result as found B, because B was there in the list of A, B and C, and F is not present. So, second message that will be displayed on the screen is could not find F. Now, let us summarize the module of templates. Template is a method which will describe one function or one class to work with dissimilar data types. The function template will describe the family of functions. A function template can be overloaded with different data types. The class template will describe the class of families. The class template can accept the generic data type where this data type will be separated by the comma separated list. A C++ standard template library mainly consists of three components. They are containers, algorithms and iterators. The containers handle set of elements. Sequential containers are pre-arranged collections in which every component has an assured position. Associative containers are sorted collections in which the real position of an element depend on its value due to the sorting principle. An iterator corresponds to a definite position in a container. Input iterators are read-only iterators where every iterated location may be read only one time. Output iterators are write-only iterators where every iterated location may be read only one time. Forward iterators have the ability of both input and output iterators. Bidirectional iterators are similar to forward iterators except that they can go toward the back as well as forward direction. The vector, string and deque are random access iterators. The algorithm has to be written only one time to work with random containers because the iterator interface for the iterators is frequent for all container types.